Hey everybody. In this video, we're going to do some examples of using the empirical rule to solve some statistical problems. And I think you'll find it's pretty simple to use and fairly straightforward. So let's go to work on some of these. Oops, wrong page. Oh, here we go. All right, so just to recap really quick, we talked about any given population of something we're studying here. The entire population lives within the curve. The area under the curve represents the population, and the following statistics are true if it's normally distributed. So that's the first thing you have to look for, normal distribution. Okay, so 68.2% live within a standard deviation from the mean, which the mean's always in the center right here, and so on and so forth. And then we talked about it, kind of broke it down right here. And let's go right down here and read a problem. I'll show you how you analyze these and work on them, okay? All right, so let's read this. It says the weight of 50 football players are normally distributed with a mean of 178 and a standard deviation of 8 pounds, okay? So when you read a problem like this, the first thing you want to do is extract the important numbers and assign variables to them that you know. The population being discussed here is 50 football players. There's 100% of them is 50 football players. Mu is 178. That's your mean. And your standard deviation, sigma, is 8. So let's make a note of that right here. And we'll go right up here and take a look at this problem. It says, what percent of players weigh between 178 and 194? Okay, so 178 is the mean. And if we take 194 and we subtract 178, we'll find that that's 16. So we're talking about 2 standard deviations to the left of the mean. Okay, so let's come up here and look at our little chart. All right, so 2 standard deviations to the left of the mean will be 34.1 plus 13.6. So what does that give us? 47.7. So this one right here, you would work it out just by looking at the chart, and this would be 47.7%. Okay, it is that simple. Now I got a couple more examples we're going to do really quick in this video, and they can get trickier. They can. All right, same set of data. Let's write down what we know. Same problem. Same n is 50. And I'm using n for the population. That may or may not be the variable that we should use. I just used it. Okay. What is the probability that a player weighs at most 170? Okay, so let's take a look at this 170 and how's it related to our mean? Okay, that's 8 units less than the mean, which means that's a full standard deviation to the left. Then we'll start looking at the words at most. Well, that's everything less than 170, up to 170. Can't go over, can't even be 170, right? Well, you could be 170. So let's go look at our chart again and try to interpret what they're saying. And 170 is a standard deviation to the left of our mean, right? So we're talking about summing up all this area right here. So 13.6 plus 2.2 plus 0.1. All right, what does that give me? 13.6, that's 15.8 plus 0.1, so it sounds like 15.9%. Okay, so when they say probability, okay, notice they've used the word probability here instead of what percent of players. So the probability that a player would weigh at most would be 0.159. Right, because probabilities are less than 1. And I guess you could report it as a percent. Since 15.9% of those 50 players meet this condition, the probability would be 0.159, which is 15.9%. Okay, let's look at another example here. All right, same set of data. And the reason I'm using the same set of data is there's just so many different types you can do, and I'm just trying to, not spend so much time, redefining every problem. We can kind of go through different scenarios here. What's the probability that a player weighs less than 162 or greater than 194? Again, find out how these guys are related to your mean. Where is he in terms of the mean? 178 minus 162, well, that's 16. So there's 2 standard deviations left and 2 standard deviations right. So what's the probability that a player weighs less than 162 and 194, or greater than 194? So we're looking to the right of 194 and to the left of 162, and that's 2 standard deviations each way. So we're looking out here and out here, right? Those are my 2 points. So it would be, what's this sum to? 2.3 plus 2.3, so it'd be 4.6. And to answer that question, again, they're putting it in terms of probability, so I would say 0.046, right? That would be the probability that the player weighs less than 162 or greater than 194. And I've got one last example to do here. We'll see what you think of this one. I think this one's pretty easy. Same set of data, right? And that's the first thing you do on every one of these problems. You write down that pertinent information, extract it from the reading. They use the word mean and standard deviation, so it's explicit. It's not, it could be hidden in there, but very often it's not. All right. How many players weigh between 170 and 186? Okay, so 170, again, we're relating it to the mean. We're 1 standard deviation left. 186 is 1 standard deviation right. So now we're living between. And if you notice this empirical rule, that's that 68.2. So we need to calculate something here. We want 68.2% of the 50 players. So it says how many players. So we need to calculate 0.682 times the 50 players, right? And sounds like there's going to be 34 players that meet that condition. All right, so that's how you would do that one. So we would report it down here as 34 players. And I got another video for you to watch after this one, and listen, you don't want to miss it, because I'm going to show you tricks with the calculator in this empirical rule, and you might like it. So check out the next video, and it'll be pretty short, I think. So thanks for watching.